Okay, we should now be able to be heard.
Can I be heard? Hello, hello. Any luck now? And can people see this okay, the board? I think that looks pretty clear. Hello, hello? No noise? They can just...
Oh, no, what's...
Oh, yeah?
Oh, yeah,
Can I be...
it's working now.
Okay.
Yeah, yeah.
Oh, maybe turn it off now, though, because I can just hear my echo. Yeah. Okay, hello. Yes. Hello, hi everyone in person and on the live stream. My name is Enzo. I'm one of the tutors for COMP1511, and today we're just going to be running through the assignment 2, which has just been released this morning. So if any of you had a read already, that's amazing. That's really great.
None of that. This morning, it was not accessible prior to that. Carry on.
Awesome. Yes. Released this morning, and you should be able to find it on the website now. If you look at the top there, there's assignment 2, and if you scroll down, there's also this beautiful image down here right next to the old assignment. You can see we really increased the budget we had for the arts. Just... Okay. And yep, here we go. This is the assignment. So today we're just going to run through the spec, talk about the starter code, talk about the reference implementation, and hopefully help get you started. Now, it's worth mentioning that you've only just learnt about linked lists. So if you went to this morning's lecture, amazing. That covered the very basics. But because maybe not all of you have seen it, or some people are still we don't at all expect you to fully understand linked list yet, we will sort of be taking it a bit easy and not going into too many details on that. But that sort of implies, yeah, this is a linked list assignment. This whole assignment is basically just do a bunch of stuff with linked lists. First assignment was we give you a 2D array, you do a whole bunch of things to it. This one's, oh, is the camera trying to track me now? Sorry. Yeah, it works now. Amazing. Okay. Sorry. Yeah, so you're just going to be doing basically a little bit of a marathon of linked list exercises for this assignment. And they're going to start out being a little bit confusing, but a lot of the things you'll do in the assignment are very similar to the stuff you do in the labs and we'll be talking about in the lectures, so don't worry too much. We are going to just repeat the same things. You are going to get some practice with it. Awesome. So premise for this assignment. It is a train simulator called Carriage Simulator. And you are basically going to be building a train as a linked list. So if you do know anything about linked lists yet, you know they're sort of we have these structs and they're all joined together and the first one links to the second one. Let's see if we can find a nice diagram down here. Stage 1. Yeah, here we go. You've got one thing connected to another thing, connected to another thing, and if you think about a train, that is very, very similar. So hopefully, as you go through this assignment, if you just sort of picture it as a train with all the carriages linked together, it might help a bit. But yes, so let's go up and we'll talk through what you're actually going to be doing. We have a few things in the starter code that I'm just going to skip over here because we'll actually just pull up the starter code and look at it ourselves. But we have a provided struct that you'll be using. This is what you'll be actually making your linked list out of. These are the linked list nodes. And we explain what all the fields mean here and what everything is. And we also have this enum in the starter code, which just defines we have different carriages, and this is a very fancy train. It's not just a passenger train. You've got a buffet cart, potentially, or a restroom cart, which one maybe not as nice to sit near, and a first class cart. So maybe think of a long range interstate train. Awesome. And yes, there's some handy tips. So I would recommend, even though I'm skipping over this, have a good read through all of the introduction. When you start working on the stage, just make sure you have a view through, you read through the text for that stage, all really before you get super stuck into it. Awesome. But we can basically just do the getting started part here. So the first thing to do for this assignment, if you want to get started, which you should at some point, is to, oh wait, actually, before we do that, this is just running through the general structure of the assignment. So in stages 1.1 and 1.2, you're just going to be getting things set up to go. It's very similar to in a stage in the previous assignment where you set up the command loop. You'll be doing a very similar thing here. And then it's really from stage 1.3 onwards where you're going to be implementing a bunch of different commands to operate on the train that you'll be building, that you'll be simulating in your code. Awesome. Yes, okay. how we actually get started. So the first thing you should do, create a folder. And you can just copy and paste these commands here. Let's go into, where is it, VS Code. Yep, let's go ls. We're in a new empty folder. You're going to do all your work inside here. And the next thing you should do is fetch the starter code. So this is the same as the last assignment, but I am going to reiterate. See this little dot at the end there? You need to copy that as well. If you leave that off, it doesn't work. And a good way of checking this is once you copy this and we paste it in here, if we now do an ls, looks like we have some starter code. And we should now be able to run the auto test cs underscore, ooh. Awesome, okay. All the auto tests will fail because we haven't actually implemented anything. But this is good. This means you're doing it right so far. So we're just going to cancel that early. Yep, so if you get to that stage, that means you have the starter code and you can start to have a look at it. So we can get rid of this and we can actually open up, ignore test.c. Here we go, and this is the code you'll be working off. So it can be a little bit intimidating. There's a lot more starter code provided for this assignment than the previous one. And what I just warn you about up front is you actually don't need to read through all of it or understand all of it. A lot of it up the top here is important. This is stuff you'll be working with. So this is the enum we just spoke about. This is the struct we just spoke about. But then if we scroll down, you'll see all of these function prototypes here. Look at all these. Okay, these are provided functions that we've implemented for you to sort of make certain parts of the assignment easier, and you don't need to know how they work. Some of them, if you're really curious, you can go through, you can have like a good explore and just like try and figure out how some of these actually work, but you don't need to know. In fact, the main thing you might need to do is you'll use one of these in say stage 1.3, and to do that, you might want to have a little bit of a read of the function comment, which explains how to use the function and what it does. All of this information is also in the assignment spec. So if you don't go scrolling through and having a look at this, that's okay too. But yes, you don't actually need to go and look at like how this actually works. And you'll notice there's a few of these functions that we've specifically labeled. Scan token, type to string, string to type. You will never need to use them in this assignment. They're functions we use to implement the ones you do actually use. You'll use these ones. You won't ever use these ones down here. Awesome. And then we have one other thing here, which is one of your function prototypes. So this is different. This is a function that you will be implementing. This is the first thing you'll do for this assignment. Okay. But before we get right to that, I will just talk a little bit about these structs at the top here. So as I mentioned before, this is your linked list node. This is the thing that's going to be making up part of your train. Basically, the way the train works is we have a bunch of these structs, and they're linked together, hence linked list, via this next pointer. If that's confusing, if you're not sure about that, that's okay. We'll be talking so much about linked lists, you'll be sick of it. Now, these things though, these are just fields inside the struct, stuff you're used to by now, same as like the fields inside the struct for the previous assignment. And we've got a few things here. We have an array of chars, which by now, array of chars, that probably means string, and that's correct in this case. This is a fixed length string, which is null terminated. So there is a /0 at the end. You can just treat it like it's a string. You can pass it to string functions if you need. We might delete that from the starter code before you download it. But yes, and they'll usually come in the form of a 1, 2, 3, 4, 5 char long string. There'll be 5 characters for the ID of your train, and the ID of your carriage, sorry. And a train is built of carriages, and each of these IDs is unique. So a train is built up of these carriages, and they each have a unique ID that they're like referred to. So one might be like ID 1 and ID 2, but it says a little string instead. Awesome. Each carriage also has a type, which is one of these enums up here, and one of these will be stored in this field here, and that will determine what type this carriage is. And then we've got 2 more fields down here. We have capacity and occupancy. Capacity is the total number of passengers that can fit in a carriage, and occupancy is how many passengers are currently in the train. So if we have a capacity of like 50 and an occupancy of 25, the carriage is half full. Half of the seats are filled. Awesome. Are there questions? Nope. Awesome. Okay. Or any questions from the crowd either so far? Nope. Okay, awesome. So these are the structs that you'll be dealing with a lot in this assignment. And your first task, stage 1.3, which we can actually scroll down to in here. We go through here.
Actually, just very quickly, someone in the chat is just clarifying that the string will be 6 characters long because of the null.
Yes, sorry, that's correct. That's a very good point. I said it's 5 characters long. There's 5 characters that you actually read and use. But yeah, very well spotted. If you look at the hash define up the top, it's actually 6. That's because there will always be that extra space for the null terminator. But you don't need to worry about that so much. You can think of it as being 5 chars that you actually care about, and then that one magic char at the end that tells you where the string ends. But very good point. But yes, so if we have a look here, stage 1.3, stage 1.1 is going to be implementing this first function that's provided for you, or the outline of it is provided for you, called create carriage. And that's a function that's just designed to create one of these structs. You might have heard about it in today's lecture, and if you haven't, you'll hear a lot about it in the following weeks, where when we deal with the linked lists, when we deal with malloced structs, it can be really, really handy to have a function that just creates it for you and then initializes everything inside it. It's so handy, in fact, that we're just like making you do it as stage number 1. Okay, we'll talk about that a little bit in a sec. I'll go through the rest of this first. Okay. Yeah, so here we go. So we downloaded the starter code, we ran this to make sure it works correctly. We will go and have a read through of stage 1 together, and ooh, this is a good point here. So for solving these, and for solving linked list problems in general, diagrams are super, super helpful, and we would really recommend that you sort of just draw things up to figure out how it works in your head. We'll talk a bit about this in stage 1.3 when we go over the tail insertion. But that sort of problem can be much easier to figure out when you can actually see the moving parts. And yeah, once you've diagrammed, once you've thought about it a bit, you can get going with the assignment. Now, all of the information you need to complete this assignment is in the spec. The spec is quite detailed, and it specifies everything you need for a stage. But if there's anything that you're unsure about, or that isn't clear, or there's anything we've missed, which does happen, then we have also given you, where is it? The reference implementation. Yes, so if you run this command on CSE, you can see the working version of this program. So if you complete all of this program from stages 1 to 4, and then the extra challenges, the whole assignment, that'll look almost identical to this reference implementation, hopefully identical. But yeah, so if you have any questions about how a particular stage works and you're not sure, you can grab this here and you can run it yourself. And here's a recommendation, which is to run it and then just run the question mark command. This one here. Okay, so if we paste this in, click enter. Oh, you can't really see very well. Let me make this bigger. Yep, and here's a working version of the assignment. And yeah, question mark command, and this just prints out all the different commands that you'll eventually be implementing. These won't be implemented for you yet. But we could run these. So for example, this one here adds a carriage with a type and a capacity. So we could run this on the reference implementation. Add n, sure, passenger, capacity 10. Awesome, that did something. Let's do question mark again. What other commands are there? There's print. Okay, let's try print. We do print. Looks like it printed out the one carriage we entered. Yeah, so you can experiment with this if you're unsure about anything. That being said, if you do find any things in this spec that you aren't sure about, also message us on the forums and let us know, and we'll be happy to sort of add clarifications to the spec if needed, if any of the stages aren't clear or we're missing some assumptions. Cool. And yes, starter code. We already sort of spoke about that. Now, allowed C features, restricted C features. One very important point for this assignment, you can't use arrays. I know you've just gotten really comfortable with arrays, but you're not allowed to construct the train using an array in this assignment. This is to prevent you just like avoiding linked lists entirely and doing the entire thing in an array, which you can try to do. We really don't. You have to come out of this assignment learning how to use linked lists, so we've just fully banned arrays. The exception is you can use strings, right? You can create your own strings, you can mess with strings. You'll need a few strings to deal with just the ID inside each carriage. But aside from that, no arrays, I'm afraid. Awesome. And there's a few other points here of what's allowed and what's not. Have a read through that in your own time. And then we get to stage 1. So, as I said before, we'll run through this together and just have a look at like what will be required in each stage. We're going to spend a little bit of time on stage 1.3 just to cover sort of some of the things you might be unaware of to complete that stage. And then we'll have a run through of stages 2 and 3 as well after that. Okay, so if we look at stage 1 is all about getting your program set up. So implementing that one function that we say you have to implement, and then implementing the command loop, which allows you to loop infinitely and scan in different operations to perform on the train. That should sound familiar. That is identical to a few other exercises you've done so far. In fact, we list them here in stage 1.2. So if you're unsure about how to implement the command loop, have a look back at some of your old work, and hopefully that makes it a little bit more clear. Yep, what else is in stage 1? Adding carriages to the end of the train, printing out carriages in the train, and checking a carriage is valid. So these two we just saw in the reference implementation. It's inserting things at the tail of the train and then printing out the whole train once it's done. And when I say train, we're really using train and link list of carriages interchangeably. Think of the train as a bunch of the carriages all stuck together. And we can see a little diagram here of what yours should look like once you're done. So this will be the structure that you have in your code. You'll have a pointer somewhere which stores the address of a carriage, and then that'll be linked to another carriage, and that'll be linked to another carriage. Awesome. Any questions so far? No, awesome, okay.
Are we allowed to convert linked list to doubly linked list?
Yes, that is a thing. I'm not going to talk about that though, but the answer is yes. You can set up this as long as you're not doing it with an array. You can really do it in however you want. If it fits the spec and you decide, I don't like how these arrows look, I'm going to implement mine so my arrows go in a different way. That's totally up to you. You are allowed to modify struct carriages and put whatever you like in them. I will say you've got to still make sure they work with some of the functions we provide you. Okay, or you've got to modify those functions. So stage 1.1, that's filling in this function we just talked about. So if we look at the starter code, we'll see there's a prototype up here which defines what the function takes in. If we scroll down here, there's already a function stub, or the shell of a function, which is just a function that doesn't have any of the logic implemented. And this is what you'll be doing in stage 1.1. So I can't show you how to do this, but it talks you through it a little bit here. You have to malloc and then set all of the fields inside a struct and then return it. Hopefully that's, anyway, I won't talk more about that just so I don't solve the stage in front of you. That would be pretty bad, I think. Okay, and then, I'm not allowed to do that, I'm guessing?
I mean, we have done it before, where we just sort of accidentally solved the entirety of stage 1.
That's very funny. Okay, I've been told by the admin to try and avoid doing the assignment for you. So I will sort of stick to that. And if we look through stage 1, so it gives you some hints, some instructions on what specifically the function has to do, some hints about how you might have to implement it, so this is something you might get caught up on, and then also some assumptions down the bottom. So these are really important because these tell you what things you don't need to worry about when you're writing your code. This here says this will always be 5 characters plus the null terminator at the end. So you don't need to check for that. You don't need to worry about if someone gives you the ID in this function and it's funky and they've done something weird and it's actually too long. That won't be something we ever test you on. So assumptions really important. If they're in there, you can sort of stress less about them. And then yes, stage 1, we don't actually have any tests. So if you want to make sure your function works properly, you have to manually run it, sort of see if you pass things into the function, they come out the way you expect. We've given you a little bit of code that you can copy into main and just sort of see if it works. In fact, we could do this ourselves. So the way you do this once you've implemented that function, you can grab all this code here, we can paste it into main. See, stage 1.2 here. We do this here. Ooh, that looks nasty. Let's do this. Let's just delete all of this. Cool. Yep. And then we run this. We would expect, if we put in this string, the type passenger, and a capacity of 20 here, we would expect to be able to print those back out. So if we had implemented this, we should be able to go DCC cs_cs.c. Oh, that's nice. Okay, it's not as nice as I thought it was. -o cs_cs. Yep, and if we run this, compiles, that's a good sign. Sorry, I'll make this a bit bigger. Actually, can this even be seen on the live stream? That's probably cut off, isn't it?
Which bit?
The very bottom of the terminal. Maybe, okay.
That's one of the benefits of being here in
Yeah, it's cut off. Where you're typing, it's cut off.
Is that something you're able to change?
No, just Control L.
We can just shift up. We'll
That
just shift a little bit up.
Okay.
Yeah, we can.
Mention in the chat if that's something. Oh, you're going to fix it? This is not my computer, by the way.
Hi.
Oh, we're just dragging the screen
There
up.
we go.
All right, that's cool. Okay, hopefully you can see what I'm typing now. So what we just did was we compiled the code. We copied in the testing code to test create carriage, which calls the function and then tests the struct that it returns. That works. Is everything okay?
Oh, yeah, no.
Yeah,
All right.
it's fine.
Okay, we run this and, oh, everything breaks. Obviously because we haven't actually, written this function yet. But if you do this correctly, you would expect to see, where is it? On this first one here, this would print out this. Capacity would be 20. Occupancy next, you might have to figure out what to make those. And then this should print out type passenger down here, because that should be the passenger that's copied inside. And once you're done testing your code and you're sure it works, just grab all your testing code and just delete it. It's not actually part of the assignment. We don't want that in there for the later stages. So make sure you get rid of it all. And you don't have to use our testing code. You can use any code you want here, just to sort of like check your function works. This is also something we'd recommend doing for the whole assignment. Test your code manually. It's really handy. Awesome. Okay. And then at the bottom here, yes, the thing I just said. Awesome. Okay. On to stage 1.2. As I said before, this is so similar to some of the programs you've implemented before. If you weren't sure about these in assignment 1 and in CS Calculator, I think I'm allowed to tell you this, but the sample solutions for CS Calculator have been released, which means there is actually code written here that maybe shows you how to do a command loop.
No way.
Yeah, which is almost the same thing you'll be doing here. So let's talk about the command loop really quickly. It scans in first one char, which tells you which command to actually run, and then a number of arguments. So each command will have a fixed number of arguments it takes in. For example, 1.3 always takes in these 3 arguments. Every time you run A, you'll need to also scan in 3 extra things. And the first one's an ID, the second one's a type, third one is the capacity. If the command was something else, if it was P, you might not have any arguments. Those are things you don't need to sort of error check. You will always be tested with the correct number of arguments for a given command. So if it's the P command, we're never going to stick like a random number after it to like see if you've caught that condition. We don't sort of want you to worry about that. It's just like not what we're assessing, and it's a little bit painful. So yeah, you do have to make sure that you implement each of these commands and you sort of implement the command loop to work the way we expect it to. And a really important part of that is you're going to need a little space before the %C when you scan in the command char, the first character of each command. Please remember that. It can be very painful for you when you don't. Awesome. Yep, and the way that this command loops is, the command loop works is you'll be scanning in these commands over and over again until Control D is pressed, and that ends your program. Again, this is very similar to these other 2 things here. Okay, and just to quickly demonstrate that, we can run this with the sample solution, 1511. And again, anything you're not sure about, you read, doesn't make sense, you can have a little play around with. So as we said before, we can sort of like put some commands in here and see how they work. And then when we hit Control and then D at the same time, it ends and it prints out goodbye, which is nice. Also note that if you are testing things on the reference implementation and you enter in some nonsense, it will crash and tell you like, hey, you entered the wrong number of arguments. This is not something you need to copy. We don't expect you to implement this. After actually writing the code for the command loop, you need to also implement one command, the help command that we've just been running, the question mark one. Now this should be pretty straightforward, hopefully, because we have actually given you the code to print out the message. We have this helper function. So this gets into where we have a bunch of starter code for you. Now this function, or procedure I should say, you don't need to know how it works. I mean, if you look, it's just a very long print statement. It's not very sophisticated, but it's all written for you there. So if we call print usage when the question mark is scanned in, you've done the help command. That's the whole command. And we can just see how this works by running it as well in main. So we can just do like print usage, and then it takes in no arguments. And this should hopefully, if we run our code, just print out that usage message. Looks good. Run the program, and we see, yeah, it just printed out that giant message. Awesome. So yeah, your job is to implement the command loop and then also implement the specific command, so anytime a question mark is scanned in as the character, it prints out this specific message. Now, for all of these provided functions that we give you, we actually specify in the stage in the spec which ones you'll need to use. So you don't need to sort of worry about, like, as you're going through, oh, which of the commands I need to use, we tell you. There'll usually be something like this, which says there's a helper function, and then a link, which just scrolls you down to where we describe exactly what the helper function does. In this case, it doesn't scroll down very far. And we also provide a little bit of some sample output to show you what your program should look like once you've implemented this command. This is all very similar to the first assignment. Cool. And yes, some of the assumptions we just spoke about. All of this stuff I'm saying should be listed here as well. And if there's anything you think that's not listed, any assumption that you think might be something we wouldn't expect of you, you can ask us on the forum and we'll clarify, is this an error case you do need to handle or not? Most of that should be very explicitly listed though. And then once you're done with each stage in this assignment, so once you implement the command loop and the help command, there's auto tests for you. So I'd recommend running these after every stage you complete. If you run these, it'll tell you if you're passing the basic sort of tests of what we expect this stage to do. In this case, we haven't written anything, so it shouldn't work, which makes sense. I would also recommend, it doesn't say this here, but you can give assignments and lab exercises as many times as you want. We only mark your last submission. Each time you give, it also saves a copy of them, so if like your computer blows up, we can get that copy and give it back to you, and sort of like, that way you don't lose any work. So test often, submit often. Okay. Once you're done with stage 2, we're on to the first really, I'd say, substantial stage. This is probably the hardest stage we've encountered so far. And this is where we're actually going to be starting to, we're making a command that does something more interesting, not just print out a message. And you've got to start doing linked list stuff. So if you look at add carriages and you're like, I have no idea what this is asking me to do, I'm so confused, it's okay, we're going to talk more about linked lists. I'd recommend go and do the labs from next week. Go watch the lectures from this week and next week first, because we will have activities that are pretty much add a node to the end of a linked list, which is sort of what this is doing here. Is exactly what this is doing here. Yep, but if we look through, it shows, okay, so somewhere in your code, you'll have an empty linked list, which is just like a pointer. In fact, I can write that. I can write this part of the solution for you. This thing here, this is just a pointer. So this is just saying we have somewhere in our code struct carriage star train equals null. A pointer with nothing there. And this is our empty train. A train sort of like just the driver's carriage, no sort of passenger carriages after it. And your job in this stage is to start actually adding carriages to the end to make it, like a train that has things it can do. And the way you'll be doing this is you scan in the A to say this is the add command. You scan in a carriage ID, you scan in the type of the carriage, and you scan in the capacity. Now, this one's easy. That's just an int. We know how to scan in ints. We've done that before. This one's a string, and this one's an enum. So these are a little bit less clear. And so what we've done is we've just given you the functions to actually scan those in. So you have 2 helper functions for this stage. They're listed here, and then, as I said before, if you need to read more about them, which I would recommend, you click on that and it explains how they work. And these two provided functions basically do that job of scanning these in and returning them to you. They work very similar to the way that scanf works, where, you know, once you type something in and hit enter, everything's just sitting there waiting to be scanned in, and then as you scan in, it just takes the next thing off whatever input you put there. We can show that here. But yeah, so we'll show those functions in a sec. But yeah, so you can see that each time this command runs here, our linked list should have an extra thing stuck to the end of it. So the first one, we'll add a carriage here. And then as we run it again, it should put a new carriage after the first one. Cool. Now, yes, as I said, let's have a quick look at these helper functions. So this here tells you more about how they work, but I'll just talk through it as well. And we've also given you a little bit of a code snippet here to just explain how you use them if you need to. And we're going to copy this and start from here. So this is all stuff you will be doing in the add command, where once the add command is run, you need to scan in the ID, the type of the carriage, and then the capacity. Now, very important here. So these functions scan in those specific things for you, but they have to be run in the correct order. You can sort of think of like, we enter here. Where is it? The ID first, then the type, then the capacity. So when you're scanning them in, they just take the next thing available that's sort of been typed. So this one here needs to be run first. We need to grab the ID first. But after you run this thing here, so we create our array of chars, once we run scan ID here, it should scan in all of the characters from the ID that was entered into this array. So after here, we should be able to do like, okay, print %s. The entered ID was this. And that should be an ID. And then likewise for this, scan type. This works a little bit differently, and if you're sort of confused about this, again, it's described in the spec, or you can go read the comment above it. But this one doesn't take in the type in the brackets here. It returns the type. So to run this, you do type equals scan type. But same thing, once that's run, it should change our type and scan whatever was typed in into here. So if we do printf, now, it's a little bit of an interesting thing here, which is, let's do this instead. So, if you remember from before, this second thing here that's scanned in, this is the type of the carriage, which is actually an enum. It's one of these enums from the top. We don't normally print those directly out because they look a bit funny. It's sort of something that tells you in your code what type this is, so you can do different things based on the type here. So instead of just printing that out directly, I'm going to say if type here, type equals passenger, print this out. Otherwise, don't print anything out. And then capacity is pretty normal. You know, that's an int. We don't need to look at that. You've scanned those in before. If we run our code now, DCC, that's okay. That's because we made our train and then we never used it. I'll just get rid of that for now. If we run this code, CSCS, it should wait, and the first thing it scans in should be, what did we say, the ID. So if I type in a valid ID here, so that's anything that's sort of 5 characters long, that scans in, prints it back out. So this function works. And you can sort of just use it exactly like this. If we scan in a carriage type, passenger, it gave us back the right enum for a passenger. And then the last one's an int, and we won't worry about that. Another really important thing here is make sure you always scan in all of the arguments to a command, no matter what. No matter if there's errors, no matter if something else happens, we're always going to give you all of these in our tests. So you should scan them all in and then check for errors afterwards. And we'll specifically tell you if there's any errors you have to check. They'll be down the bottom, like here, which in this case there are not yet. Cool. Yep, there's a few handy little tricks here with the carriage, the scan type function. I'm not really going to worry about them here. And just in case you were curious, when you type in passenger, it converts that into the correct carriage type. And this down here just shows you which sort of words get turned into which type. So if you want to make a first class carriage, you type in first_class. Should be pretty intuitive though. Okay. We also provide examples here. So when you run, once you've implemented this, if you run this down here and you provide these exact same arguments in the exact same order, so you run the commands the exact same way here, you should produce the exact same output. So these show exactly how your code should work. And if your code looks the same as all that, you're welcome to run the auto test and see if your code sort of matches up exactly. Now, just one last thing here. For actually adding the carriage, I can't show you what that looks like in code, and that's very much like a linked list problem, which, as I said before, you might not be super comfortable with. But we said use diagrams, and we've provided you with diagrams here, right? We've provided all these diagrams that show what the train looks like at each stage, and we want you to basically do stuff like this yourself. And to make that easier, there's a little button here that says click to expand diagram. So if you can't see stuff properly, you can click that, you can look closer at the diagram. We also have this little edit button down here. This should hopefully be helpful. If you click this, you get your own copy of our diagram, and you can sort of run through the motions of figuring out how an insertion would work. So for example, you might say, okay, well, this is what my train looks like right now. So to insert a new carriage at the end, I need to go through, I need to figure out where the end of my carriage is. Oh, that's the end here. And then I need to change this arrow to point to a new struct. So maybe first you create one of these, and then you sort of figure out, okay, how can I figure out where the end of my list is? You loop through, you find the end of your list. Oh, this is the end right here. So then we can change this thing here to point to a new struct carriage. If you run through things sort of visually like this, it can help with a lot of the problem solving. Okay, if there's no questions about that, we'll move on. Stage, what else is there here? We have, yep, that's the end of stage 3. Stage 1.4 is just printing out your train. It's worth mentioning that because you add stuff in stage 1.3 and then you're actually looking at the train in stage 1.4, it's very possible that you implement the add command and you don't properly insert things at the end of your list and you don't realize until you go to print it out. So just be aware of that. You might have a mistake in stage 1.3 that trips you up in stage 1.4. Because there's sort of no way you can actually tell that the carriage is being put at the end here until you can look at it. The good news is, once you've implemented stage 1.3 and 1.4, you can add things to the train and you can look at the train. You can print it out and see what's inside it. And once you're there, a lot of the assignment becomes a little bit more intuitive because you can view what you're doing. You can actually have like a visual idea of what's going on in your code. Yep, and once you're done with that, there's an auto test. Okay, now stage 1.5 is a little bit different. There is no new command for stage 1.5. If you read through this carefully, it tells you that what you'll be doing in this stage is adding some extra code to stage 1.3. So in 1.3, we just sort of added the carriages to the end of the train no matter what. But there's some carriages that aren't correct. And so you'll have to take your code from 1.3 and add some error checks in to make sure if the capacity is negative or if the carriage type is invalid, then it doesn't get added to the train. And what this will probably look like in your code is the way that you add the carriage to the end. You'll probably take that code and you'll just put it inside some if statements to say like, if some things are true, then we add the carriage. Now, anytime you go back and edit old code, you will run into the issue that you might break it. So what we recommend here is as you're modifying your code to sort of make it work here, do keep auto-testing stage one, the previous stages, do keep checking as you go that you sort of haven't regressed what your assignment can do. And yes, here it says, even if there's errors, you still need to scan in every argument. This defines exactly what the error conditions are for stage 1.3. As we said, it's if this is invalid, and that just means if they type in any sort of string that doesn't line up with the carriage type, the scan type function will actually return, instead of passenger here, it'll return this one. It'll return invalid. And if it returns that one, that tells you whatever type was typed in isn't correct, and you need to sort of report an error for it. If the capacity is out of bounds, then you need to print out an error. And then this last one's a little bit trickier. As we said before, carriage IDs need to be unique. So to check this, you need to figure out how can I find if an ID exists in my train yet or not. And if it doesn't exist anywhere in your train, in your linked list of carriages, then that ID is unique and you're safe to add it to the end of the list. Yes, and there's a little bit of advice here about how to split up your code. You don't need to follow that, but it's there in case you sort of find it helpful. Okay, and then if you get through that and you auto test here, you're done with stage 1.5 and you have like a fully working train in your code and you've made really good progress. You're on the right track. Oof. Sometimes I shouldn't say the things that come into my head. I don't get fired for that, do I? Thank you, that's very kind. Okay. Now, how much time do we have? We've got 15 minutes left. I'll run...
Yeah, 15.
15 minutes, yeah. Yeah, so I'll do a quick run through of stages 2 and 3 and just talk briefly about what they involve. Stage 2 has a lot of just extra tasks you need to do on your linked list now that you have it built. So we have a different type of, a different way to insert carriages. This is something that will be covered in the lectures as well. So this type of linked list insertion, you will see example code for how it's written. And we've got some diagrams as well to sort of help you figure out how it works. We also have now modifying data inside your linked list. So you have this linked list of carriages and all of the occupancy fields, all of the carriages are actually empty. So in this stage, you'll be adding passengers. And that's about finding the correct carriage and then modifying the number of passengers inside there. And there's a little trick here, which is that when you get on a train and you get into a carriage, if that carriage is full, you don't sort of just like get off the train, or you don't sort of just like sit on someone's lap. You have to move and find where an empty spot is. So you'll be implementing something similar to that, which is when you load passengers onto one carriage, if they can't fit there, they'll actually overflow into the following carriage and try and find a seat there. You've got to implement that logic in your code. And you might find it helpful to just play around with that using a diagram or with a reference implementation. The other thing to mention in this stage is that some of the stages will have a bit of overlap. So here you'll implement remove passengers, and this is just like taking passengers back off the train, and there's no sort of overflow mechanic here. And then count passengers, which is counting the number of passengers in either the entire train, if the T command is run, or between two specific carriages. So if we look at our diagram of the train, we can go back up to here, we might say, tell us how many passengers there are between this train, this carriage and this carriage, and you've got to loop through and figure out in just that segment. Now, the code for figuring out how many passengers are in the entire train and in a particular segment, there's a lot of overlap there. And you'll actually find that in a few of these stages, there's quite a lot of overlap in the code that you will be writing. So in this case, you might find a way of using almost the same code for all of C and all of T. If you can do that, that means that you've written one block of code that works for both, which is more reliable because then you actually have to test one piece of code, and you might find other places you can reuse that code as well. So we'll actually be assessing on how well you can break up your code into these reusable functions. And you might notice that it's also helpful here in stage 2.5. 2.5 here, you're moving passengers around in the train, and this very likely will have quite a bit of overlap from stages 2.2 to 2.4. So it's something to look out for. If you can't figure it out, don't stress too much as well. The most important thing is to get the code working. So if you can't find the optimal way to reuse things, that is okay. Okay. All right, last part of the spec that I'm going to cover here is stage 3. So this is quite a while away, and you sort of don't need to stress about this too much yet, but stage 3 is a big shift for the assignment. Before we were just working with one linked list. As we said, looks like this. We've got our pointer to the start of the linked list. We've got carriage, connects to another carriage, connects to another carriage, connects to the end. In stage 3, you have to take that linked list and you have to put it inside a linked list. So you think, we had 2D arrays before. This is kind of like a 2D linked list. It's a linked list of trains. So we go from having lots of carriages inside one train, we can add more carriages to that train, to having lots of trains, and we can add carriages to any of them. So we can sort of think of this as like this is a station or a train depot where we make lots and lots of trains and then switch between them. And stage 3.1 is going to be talking you through the process of converting your single train into a train that's inside a struct train, so we can put that in a linked list as well. That process might be a little bit, you will definitely have to go back and edit your code from stages 1 and 2. And because, as I said before, anytime you go back and rewrite your old code, there's a chance you're going to break things. So again, through this entire process here, you're really going to want to just like auto test a lot. Just make sure every time you make a change, things still work. All of those hints are written here as well. Okay. And then stages 3.2, that's just dealing with more of the multi-train stuff. So it's printing out your linked list of trains of carriages. More important probably is to talk about 3.3 and 3.4. In these stages, you're going to be removing carriages or trains from your linked lists. And the important thing here is you'll have to use something called free, which you might have heard a little bit about, might not be super familiar with yet, but every time you create memory to put it into your linked list, you've also got to make sure that that memory either stays there or it gets destroyed. Because eventually, we want to make sure every bit of memory that was created does get deleted, does get destroyed, so that your code is leak-proof. No leaks in the train sort of thing. We basically want, by the end of 3.4 here, that any piece of code, any piece of data that you malloc also gets freed. And this will be added to the auto tests from stage 3.4 onwards. This might mean code that you wrote in an earlier stage had memory leaks, and that is stopping your code from passing 3.4. So be aware when you go to this stage and you sort of implement the logic to delete an entire train, if you check all that code for memory leaks and it's all working and you can't figure out what's wrong, you might want to also go back and double check stages 1, stages 2, anywhere else you add things into the train, you create memory, there's an avenue that you might be leaking memory. To assist with that, you can use the dcc-leak check command. We'll talk about this more later, which sort of helps you know, well, it basically identifies when you've leaked memory. And then I think we're not going to talk about stage 4. If you get up to stage 4, that's great. It's going to be challenging, hopefully, but that's sort of the fun of it. And then if that's not challenging enough for you, we also have extra challenges. So if you sort of like get this assignment done in a day and you're finding everything easy, which that's cool, we have this section here, which is hopefully, will keep you entertained till, the end of term. We might add some more challenges here, we might not. Basically, nothing in challenges is accessible. Stages 1 to 4, worth marks. Stages challenge 1.1, 1.2, not worth marks. Do them at your leisure to entertain yourself. Don't do them because you're like trying to get all of the marks in the assignment.
Like the skull exercises in labs, they're purely just for your enjoyment.
And there's even a skull here to represent that. So yes, the skull is to show that you'll have fun, yeah. Awesome, okay. Now, let's talk a little bit about admin stuff in the last 10 minutes. What do we have at the bottom here? Okay, so we've got the challenges. Is there anything else I should mention? Is there anything else obvious I've missed that needs to be mentioned?
No, I think in terms of the content, that's all.
Awesome. Okay, so whole bunch of like admin stuff that you should read through and make sure you understand. Don't work on this with someone else. No pair programming for the assignment. No sharing your code. I'm sorry, I see some very sad faces in the audience. Just out of curiosity, what was your name, just so I can... yeah, no, don't share your code. You've probably heard this before, but if you are sort of struggling with the assignment and you're considering that sort of avenue, please come and talk to us first. Please let us know that you need extra help, and we will do our best to sort of give you that extra assistance. There's so many avenues that don't involve plagiarism and academic misconduct. Now, you'll also notice here, no writing your assignment using GitHub Copilot. I'm sorry for the people who like GitHub Copilot. And ChatGPT. Any code synthesis tool you can't use, write the code yourself. It'll be very, very helpful. Come back to it later. You'll know how to solve problems. It'll be great. Yep, no sharing. These are all pretty standard. These are the same from the first assignment, so if you're familiar with them there, you should be familiar with them here as well. Basically, do the code yourself. Don't show other people, unless it's a member of the staff. Tutors can look at your code. We can help you out, and we can sort of help you solve problems if you're stuck on anything. Awesome. When it's time to submit at each stage, which is again, submit often, there'll be a give command listed. I mean, I probably can't demonstrate this because giv's probably not set up for me, but if you run this, is it? Oh, all right. Wait, I mean, so yeah, once you've done a section of code, you should be able to run this. And if you do it, it will sort of take a little while because it'll probably start running some tests on your code, which we're going to fail all of them. Once that's done, you type yes, and then yes again. This is stuff you've done for the other lab exercises and the other assignments. But this is what actually submits your code to be marked by us. We take the last one of these. If you forget to do this, it's not so good. We don't actually have a submission of your code to mark. So remember to run give. And then, yeah, okay, marks. All right. So this is a rough outline of the breakdown of marks from stage to stage. Don't take this as sort of gospel, because there is a little bit of variance in the way the tests will be written. And there's also a little bit of variance here in that, okay, stage 1.2, oh no, stage 1.3, sorry, that's adding to the train, which is worth 10%. But as we said before, it's hard to tell if you've actually added the carriages to the train until you print it out and see that they're all there. So this is a rough outline of where the breakdown is, and this might help you sort of prioritize, oh, maybe I'm up to stage 3.1 and I might just do 3.2 to get the extra 5 marks, that sort of thing. But this just shows you all the different stages and the rough amount of mark. The other thing that you should use this for is that stage 1 here is worth approximately 35% of the performance mark for the assignment, which means completing stage 1 gets you to about 35% out of 80, which is the performance percentage, and then there's an extra 20% that is style. And you'll notice if you get through stage 2 as well, and then you get really good style, that's a credit. So this will hopefully help guide you to what each stage is worth and where to spend your time. But yes, this is percentages of the performance mark. We also have style, which is listed down here. This is what we'll be marking your style off. It is, I think, identical to assignment 1. So it'll be the same things we told you to focus on there, you should focus on here, with more of an emphasis on things like breaking up your code into functions. We sort of expect a lot of your style to have, I guess, you've gotten more comfortable with functions now, so you might be using them more often. But if you sort of write really good style and you get very high marks for that, then you can expect getting to stage 2 to get you about a credit. Awesome. And I think that brings us to the end here. Oh yeah. Also for style, please look at the style guide if you've got any questions or ask us. This lists everything that is allowed and everything that is not allowed. This is sort of our book of truth when it comes to style. Anything else I should mention, or is that, I think that might be it.
No, I think that's happy days.
Awesome. Are there any questions from the crowd? Anyone unsure about anything? Nope. Okay, thank you so much for tuning in. Hopefully this was helpful. Good luck with your assignment too, and I hope you have fun building some trains and stuff.